right, we are looking at our first target of the new year, target 6.1 Mastery Learning Objective. I can extend the midpoint formula to partition a line segment into any ratio. So the first thing we're going to look at is what a segment is. And a segment is simply a line connecting two endpoints. Right, so if I have any 2 points, right, here's our segment. Okay? And then we want to extend the midpoint formula to partition a line segment. So then we need to know what the a midpoint is and what that midpoint formula is. Okay? So a midpoint is a point on the lines segment that is equidistant from the endpoints. So a point on the line segment that is equidistant from the endpoints. So if I put my point here, right, and I say this is the midpoint, okay, then that means this distance and this distance are the same. It's exactly in the middle of those two. Okay. Now everything we're going to be doing in this unit is coordinate geometry. So everything has coordinates, an x and a y, right? In class we looked at graphing a lot of points to kind of get us into all our coordinate geometry. So our midpoint formula, the midpoint formula gives us a point. It's an x and a y, okay? And how we find it is taking the average of the other 2 points. So we take our x1 and our x2 and divide by 2. And I take my y1 and my y2 and divide it by 2. It's an average of your 2 x's and then an average of your 2 y's. And that's your new x and your new y. So let's look at some examples. The endpoints of RS are R is at 1, -3, and S at 4, 2. Find the coordinates of the midpoint M. So basically what this says is our first point is our x1 and our y1 and our x2 and our y2. So again, we're finding the average of our x's, so 1 and 4. And the average of our y's, -3 and 2. So 1 plus 4 is 5 halves, right? 5 over 2. And -3 plus 2 is -1 over 2, right? So we really just did the adding there. So 5 over 2 and -1 over 2. If you can divide, you should. 5 halves, -1 halves doesn't reduce. That is your midpoint. Same exact thing looking at, or similar to looking at example 2. The midpoint now is 2, 1, and one endpoint is 1, 4. Find the coordinates of endpoint K. So this is telling me one endpoint. This is my x1 and my y1. And I don't know my x2 and my y2. So I'm going to do 1 plus something and 4 plus something. is ultimately going to give me this point. Okay. X's go with X's. So 1 plus x2 over 2 has to equal 2. I'm going to solve this. Again, I'm just going to get rid of this fraction by multiplying by 2. If I'm dividing by 2, doing the opposite is multiplying. Okay. And then I'm going to subtract the 1, and I get x2 equals 3. I'm going to do the same thing. My y's go with my y's. So 4 plus y2 over 2 has to be 1. Multiply both sides by 2 to get rid of the 2. 1 times 2 is 2. Subtract 4 from both sides. And you get y2 equals negative 2. A lot. That's okay. So our final point is 3, negative 2. Okay. So you can work it backwards. All right. So the next thing we're going to look at, now that we have our midpoint formula, is to extend this into any proportion, basically. So partitioning a line segment is finding a point cross that off there. On a line that partitions into any proportion. For example, the midpoint is 1 to 1. Okay? So the midpoint is a very specific example of partitioning a line segment. When I find the midpoint, I'm separating my line segment into a proportion of 1 to 1. There's the same thing on one side of the point as on the other side of the point. If you look at example 2, the coordinates of P that partitions the line segment 3 to 5. So I'm now going to be messing with these numbers. Okay, midpoint is always like a 1 to 1. I'm going to change them around, and they can be anything I want now. Okay? So if I want to partition something into 3 to 5, I want to change my ratio into a fraction. So that's step 1. Go back and spell. Change ratio into fraction. Okay. So what we do is, if I'm thinking of that going from the beginning, I first want to go 3 parts. And then total, I went 3 parts and then 5 parts. So my fraction is 3/8. Okay, so it's the first one over if you added them all up in total. Okay. Second step. Find x distance Okay. A lot of things we're going to be doing here, we're going to have a graph. So with your x distance, you can just use the graph to count your x distance, or you can do the algebra for it. X distance would be your second x minus your first x. Okay? Which in this case is my second. If I'm going from A to B, this is a directed line segment. It's the start to the end. So this is x2 minus negative 8. Be careful with the minus and negative. I do need both symbols there. And then 8 minus negative 8 is 16. Or, which makes sense, right? If I go this way, that's 16. Nice and easy. Okay. Same thing with my y distance. Okay. It's 3 minus negative 5. Again, we'll change that to plus. Right? Minus a negative is the same as addition, right? You can change both signs. And so we get 8. Which again makes sense if I just count as well. Right, that's 8. Step 3. Multiply distance by fraction. Okay, so for my x, I have 16 times 3/8. Feel free to use a calculator, but that is 6. For my y, I have 8 times 3/8. And that is 3. Okay. Last step. Find points. Again, there's 2 ways to do this. You can do x1 plus step 3, okay, which in this case would be our x1 is 8, so we have negative 8 plus 6, right? That's coming from here. So negative 8 plus 6 is negative 2. Okay? So if I go, or I can start at my point and move over that far. So instead of going 16, I'm only going to go 6. 1, 2, 3, 4, 5, 6. And I'm at negative 2. And then do the same thing with your y. You can do y1 plus blank. Our y1 is negative 5 plus 3, which is negative 2. So I'm going to go, right, same thing, I'm going to go up 3, right, instead of going up 8. And hey, there's our point. Okay, that point is negative 2, negative 2. Alright, so I went 3 out of 3/8 of the way. Over here would be 5/8 of the rest of the way, right? With all the steps, it seems like it takes a long time. It really doesn't. We'll do like 2 more examples, and they'll go a lot faster now that we have what we are doing down. Okay? So go ahead, turn the page. Again, our first step is finding that fraction. So we want to separate this segment into 3 to 1. I'm actually going to put our endpoints on the graph first because it'll make it easier. So we have C at 6, negative 5. Here's our C. And D at negative 2, negative 1. Again, these are directed line segments. They have a direction. It has to start at C and go to D. So this is our first point, and this is our second point. Okay. So finding that fraction, right, we have 3 over 3 plus 1, which is 3/4. Nice and easy. Then we need to find our distances. Okay? Again, our x distance is x2 minus x1. Our x2 is that -2 minus 6, which equals -8. All that -8 means is I'm going left 8, right? Same thing with y2 minus y1, which is y2 is -1 minus -5. Again, we have that double negative, so we can change it to plus. So -1 plus 5 is 4, which makes sense, right? We're going up 4. Our next step is to multiply. So we take these numbers, -8 times 3/4 and 4 times 3/4. And we get -6 and 3. The same numbers as before. And then our last step is to actually find that point by going that distance, right? So instead of going 8, I'm only going to go 6. And instead of going 4, I'm only going to go 3. Okay? So I'm going to take x1 plus blank. Our x1 is 6 plus -6. Which is 0. Same thing with our y's. Our y1 is -5 plus the number we just got, which is 3. And we get -2. There's our point. 0, -2. And that is 6 over 3 up. Alright, so this one went a lot faster than our last one. It's really not that many steps. The one thing that takes long is you do have to find it for your x and your y. We're going to do one more example. And then we're going to do example 4 in class. This one I'm going to do pretty much all by using the graph and less of the algebra. So, we're going to find the coordinates of Q that partitions the line segment 1 to 2. Our endpoints are R at -7, -2. That's our first point. And S is at 2, 4. That's our second point. Okay. So it's going from here to there. Okay. So again, I do have to find my fraction first, which is 1 over 1 plus 2, which is simply 1/3. Our second step is to find our x distance and our y distance. I'm not going to do any math here. I'm just going to count. My x distance, I'm going over from -7 to 2. If I count all these, this is a distance of 9. If I go up, that's a distance of 6. Nice and easy. I do still have to do my multiplication for step 3. So I have 9 times 1/3 and 6 times 1/3. 9 times 1/3 is 3. 6 times 1/3 is 2. Again, feel free to have to use a calculator, right, for all of these multiplication steps. Then for our step 4, right, we have to find the point. Well, this is now our x distance, and now this is our y distance. So I'm going to start at my first point, right, my starting point, and instead of going 9 and 6, I'm just going to go 3 and 2. And if I drew my line better, right, it would fall on that point. And we have it -4, 0. And there's our point. So a lot of algebra you don't have to do with the graph. I'll put those in so we know where these numbers and lines are coming from. Okay. All right, that is it. I'll see you guys tomorrow.